We have seen how to draw Eulerian graphs, how to obtain the Eulerian circuit, verifying whether a graph is Eulerian or not. We saw something about isomorphic graphs. We were playing around by checking if two graphs are isomorphic or not. Now, moving on to Hamiltonian and planar graphs, it is out of scope of this course to check whether graphs are Hamiltonian or obtaining a Hamiltonian circuit, and the same holds true for planar graphs as well. If you remember, the professor had mentioned that it is hard to find out if a graph is Hamiltonian or not, right? The same holds true here too. It is out of the scope of this course. Now, there is a simple command to check whether a graph can be colored or not, and we can also obtain the colors. Let us see how. As in always, I'll start with import network X as NX. Now, I'm going to create a graph G is equal to NX.complete graph on, let's say, 5 vertices. Complete graph on 5 vertices. Now, the command is nx.coloring dot greedy underscore color of G. You must be wondering, what is this greedy color? Well, greedy coloring is the name given for the approach which is followed to color. If you're interested, you are welcome to refer and check what is greedy coloring. It is an algorithm which uses the greedy approach to color the graph. Now, you see here, we have drawn a complete graph on 5 vertices with labels 0, 1, 2, 3, 4. Now, since it's a complete graph, we need n colors, that is 5 colors. So, what are the colors given here? 0, 1, 2, 3 and 4. So, this is called as dictionary. Do not worry much. The numbers before the colon represents the vertices and the numbers after the colon represents the colors. Now, let us check for the star graph. H is equal to nx dot star graph on, let's say, 6 vertices. And I'm going to do this nx dot greedy coloring of H. So, do you see that 2 colors suffice to color the star graph? The center vertex gets this color 0 and all the other vertices get the color 1. Now, let us generate some random graph nx.gnm random graph on, let's say, 10 vertices and 12 edges. Now, I'm going to color this graph K. Do you observe that on 10 vertices, this graph has been colored, right? You can probably draw some graph and check if the colors match it.